All right, guys, I talked about in the last video that I just made that there are a couple of vocabulary terms that we will be wanting to use that might make our lives a little bit easier. So one thing that I'm going to continually reference, and hopefully this is helpful from now on, when you see A or F or N or whatever of N minus 1, that means the previous term. So when you're in a situation where you want to reference the previous term, just use a of n minus 1 or b of n minus 1, whatever the function is of n minus 1, because that's talking about not the nth term, but the term before it, n minus 1. Okay, so what we're going to do here is we're going to write recursive sequences, or write recursive formulas to define these two sequences. So our first sequence starts with a 2, then becomes a 4, then becomes an 8. It's our job to figure out what it is that's happening here. If this is an arithmetic sequence, meaning we have addition or subtraction, then a 2 becomes a 4 by subtracting 6. So let's see if that works when we do negative 4 minus 6. Is negative 4 minus 6 8? No, it's not. So that's not going to work. So let's try a different type of sequence. Let's say maybe it's geometric. What could we multiply 2 by that would give us negative 4? If I divide both sides of this little equation that I've created by 2, I get negative 2. So let's try doing 2 times negative 2. 2 times negative 2 is negative 4. Now what if I do negative 4 times negative 2? I will get 8. All right, so it looks like we've figured out what the pattern is here. So we're going to define our recursive sequence always by just stating that our first term, we'll call our function a, first term is 2. And then the second part of our recursive definition says that if I want the nth term, and then it tells me what I need to do to get that nth term. So remember, we're saying that in this sequence, in order to find any term I want, I just have to take the previous term and multiply it by negative 2. All right, so it's going to be negative 2 times whatever the previous term is. And remember how we define the previous term, a of n minus 1. Okay, so I'm using subscript notation here, so a sub n minus 1. And this function gives us all the tools we need to find any term in this sequence. And I could prove it here by testing it. Let's say I want to find a of 4. All right, well, I'm going to do negative 2 times a of 3. It looks like a of 3 is 8. So that's just negative 2 times 8. And clearly you can see that we are continuing the sequence then. If I'm just doing 8 times negative 2, that's exactly what we defined the sequence as. So the fourth term would be negative 16 and so on. All right, so we've defined that sequence. Now that's because this was a geometric sequence. That's something we're going to start talking about. This is a sequence involving multiplication. And our next one, we're going to again have to check to see, are we dealing with a geometric sequence or are we dealing with an arithmetic sequence? So we know that there is a pattern here. Hasn't been specified what it is. Let's test and see if it's arithmetic first. If it's arithmetic, then we're using addition or subtraction. So we would have to do 5 minus 5 to get 0. And 0 minus 5 to get negative 5. Looks like that checks out. So the good news is we are using an arithmetic sequence. So we're dealing with addition or subtraction. In this case, it's subtraction. Okay. So if I am just subtracting 5 every time, I'm going to start off with, let's call this b. So b of n, we'll use function notation this time just to change it up. B of 1 is 5, because this is the first part of our recursive definition. We got to talk about what the first term is. And if I want to find any term after the first term, all I have to do is take the previous term and subtract 5. And how do I write the previous term? In this case, it's going to be b of n minus 1. So I'll take b of n minus 1. And I will subtract 5, and that's going to work for any term in this sequence. Again, I could test it by just taking the next term, I know that logically the next term would be negative 10. Okay, so let's check it here. If I try my recursive definition and I try to find the fourth term, looks like I need the third term minus 5. I can see here that my third term is negative 5. So that's going to be negative 5 minus 5, which is negative 10. It checks out. So both of these worked. All right. Tonight in homework, you guys are going to be building these recursive definitions and recursive formulas for these sequences. So hopefully this video is helpful.